Hi, I'm super excited to show you how you can use NVIDIA TAO in Edge Impulse to train custom models in minutes. My name is Jan Jongboom, I'm the co-founder and CTO at Edge Impulse. And let's actually use NVIDIA TAO v5 to go build a custom model to solve a computer vision use case. So this is the Edge Impulse Studio. It's our UI from which we do data collection, model training, model validation, and finally deployments. And as I like to say, everything always starts with data. Um, So let's build a very simple two-stage classifier. So I need to connect the device. Um, I can connect any device or development board. We have really nice CLI tools, for example, for Linux that you can run on your Jetson Nano dev kit. We have really good firmware on deep embedded devices like MCUs to collect data. Or in this case, I'm sitting behind my computer, plus I'm in Lisbon, so I don't have a complete set of dev kits with me. I can connect to my computer. So let's go fetch some data of, well, me. Hi, I'm Jan. Hi. And let's actually grab some data of not me. So the room. So let me dive away. This is only a small subset of data, but this is how easy it is typically in Edge Impulse to build these types of data sets. I've added some 237 items already prior. So this is some stuff that I collected now, and this is some stuff that I collected earlier here in the hotel. We try to make it as easy as possible to get this data in. We have some really, really great data visualization tools through our Data Explorer, which tells you mislabeled data, cluster data, whatnot. Really good ways to ingest data. We don't just do image classification. We also do lots of stuff with time series, audio, whatnot, and even a CSV wizard if that's the data format that your customer has their data in. Next, we want to create an impulse. So impulse is what we see as a machine learning pipeline consisting of data normalization. In this case, we have an image data set, resizing it to 224 by 224. A pre-processing set, here we don't do much with it, we just have an image set, and then a learn block. Here we have a classifier. We can do transfer learning, in this case on images. That's how we implement the TAO blocks for now. We can also do anomaly detection, do stuff on non-images, weird radar, event cameras, accelerometers, current sensors, and whatnot. This looks like a good basic impulse. I've already configured our image block. So let's actually go to the interesting bit of adding a machine learning code. So we have our block sitting here, and to choose one of the TAO models, I click choose different model. And here we have a whole bunch of pre-built blocks that we already have, MobileNet based, for example. We pull in stuff from the community, like for example, an EfficientNet block, and we can list all the NVIDIA TAO blocks here. So here we have one from the V5 pre-release, the Fantiny 8 P4 hybrid model. A very catchy name. We can list it actually as being created by NVIDIA or created by the TAO team. And if someone wants to build something on top of this model, retrain this model with their own data, the only thing they need to do is click add. And there we go. I've lowered the learning rate a little bit because this model is really big and we have a small data set. And let's actually go train that. So when we click here training, we are spinning up an A100 GPU. We're loading the TAO Docker container, the one underneath, and then we augment it with a little bit of code on our end, mainly to convert our data set. So for example, we do the splitting into a training and validation set, and to create the YAML file that will configure how to train. I'm going to let this run through. It takes about 7 minutes to train this model, and then I'll be back. All right, so our model is trained now. We have about 95% accuracy here on our validation set. We can dive into specific examples that have failed. Here, this one is from a different type of camera. Okay, that's an interesting one. We can dive into that. We got some really, really good data quality tools and whatnot. I won't dive into that, but if you go look at our docs, it's very easy to find. Right now, this model is really big, so we tell you that's actually one to run on MCUs with the reason. Unfortunately for this model right now, we don't have inference time. So one of the cool features in Edge Impulse is that we have a lot of different development targets from a very wide range of silicon vendors and architectures where we can benchmark. So a bit of extra work that we need to do together with the TAO team to get that up and running. But we have a model, and that model seems to work. So let's actually go to deployment to get the stuff to run on device. So we can deploy on way wider range of devices than just on NVIDIA targets. If I want to talk, naturally we do support a lot of this. So for example, if we want to run this on one of the Jetson family devices, I can just get a TensorRT library. We use TensorRT underneath anything where we can't use TensorRT, for example, signal processing, normalization, post-processing, will run in software. That goes well. If we want to run this on something else, I can grab our C++ library, completely portable. We ship hardware acceleration wherever we can. And if we have smaller models, we can even run this on the smallest MCUs we have. And then we have a very wide range of extra accelerators, deployment targets, dev kits, and whatnot here. But if we run on a Linux device, we can just build straight for that target in one go. Let's actually do that. So what I need to do is just run Edge-Impulse Linux Runner. We'll detect where we run, in this case on my MacBook. We will compile a model file, including all the hardware optimizations and whatnot. And then we have a little runner application that we're going to demonstrate. So we do this on a wide range of architectures. So both ARC64, ARMv7, weird accelerators, etc. So to test it out, we spin up a web server. So this all runs locally here on my computer. Let's open that up. There we go. That is Jan. That is not Jan. And that is Jan again. Naturally, this runs in a this shows a web server, but you can talk to this model through our Python, Node.js, Go, and C++ SDKs to integrate that into your application. That's how easy it is to build a model from scratch using NVIDIA TAO to have access to the latest architectures, but using Edge-Impulse for all of the infra, data collection, training, etc. There's some other really cool, interesting stuff in Edge-Impulse. One thing I want to highlight is the Eon Tuner. So this is our AutoML pipeline, which lets you find the optimal configuration of your models. And naturally, now that we've added here the FanTiny 8 P4 hybrid model, we can also run the Eon Tuner against that. So for example, here I have this same data set and I ran this with a couple of configurations. So here with different learning rates, actually, see what would the optimal value be. So we run all of these variants. We can compare that against, for example, an efficient net model. Once we have the profiling working, we can also have latency targets. So for example, our latency target here is 300 milliseconds, need to run in less than that on the Jetson Nano. Give me the models for which that stuff actually fits the bill. Really easy to compare, really easy to go, and naturally one of the places where we can just throw more compute at it, which is awesome if that's one of the goals of NVIDIA. And as I said, this all runs on the A100, a T100, yeah, one of those. So a little bit of background, like how easy is it to wrap a TAO model in Edge-Impulse? Well, this is how easy it is. So we have a Docker file that literally just inherits from the TAO toolkit pre-release. Then we add a couple of our own little requirements, and we have a run script, and that is just responsible of passing the parameters we get from the studio, like in our case the epochs and the learning rate, and feed that into the TAO scripts. So our run.sh file takes the epochs, the learning rate, the data directory. So we pass our data in a specific format, which is different than what we have in TAO, but not that different. So we first convert our data set and we create our YAML specs file. Then we call just the TAO scripts to train this model, evaluate, and then finally export to Onyx. And one small thing is we add a batch dimension to the Onyx file. And that's it. All the other conversion, that already happens in Edge-Impulse. The profiling of that happens in Edge-Impulse. And the deploy pipeline we handle after that. So yeah, that's TAO and Edge-Impulse. I think the combination of these things is really interesting. It allows us to benefit from the work that NVIDIA is doing in getting new model architectures like FAN up and running really quickly for our customers. I think it helps Edge Impulse. I think Edge Impulse can help NVIDIA in making it really, really easy to get the latest research and all of these enterprise features that NVIDIA offers into the hands of more developers than ever and make this a really unified and streaming experience. Edge Impulse right now, we have over 80,000 developers already on the platform. They've created around 200,000 projects already. How cool would it be if we can give all of these developers access to TAO in this way? With that, I want to thank you and happy to dive into anything more if people have more questions.